in the solid surface, and the fact that it has grooves shows us that it's a solid surface, and because if it was liquid or gas, any grooves would be filled in. So this is a solid, very dense object, and it's spherical in shape. It looks blue. It seems to emit blue light. You can see there's a brighter spot here, and it seems that it gets lighter blue from this point on the object. So it has a brighter point. And as we move further away from this point, it gets darker blue. And here we see the object like it was first observed in May of 2017, and it looked like it had stripes. But this material that makes up its stripes was already being shed. You can see a hole developing here. You can see a lot of this debris that's coming from the object surrounding it. So it shed much of the material, and this is what it looked like in July of 2017. By then it had shed a lot of that material, and we can see the blue surface. The surface has grooves in it. It's therefore solid. The yellowish material clinging to it, and seems to be forming this sort of gaseous cloud around it as well. It's being shed, but a lot of this material is in the solid phase. As you can see, it's clumpy, and the object seems to be building up a gaseous atmosphere, as you can see here, which emits magenta or pink light. And this gaseous material must therefore be ionized or in the plasma state in order to give off this color of light. And we can see that the surface gets progressively lighter in color from one circular spot. This is the circular spot, and this shows that the object is gaining energy and gaining the ability to become brighter and emit brighter or more intense light from the surface itself, from its core, or the surface of its core. So the debris formed from the stellar core shedding their old outer layers is often seen floating around them. So we can see it here and the sun. This material is not attracted toward the sun or the stellar cores, indicating that the strength of the gravitational attraction between it and other objects is zero or very close to zero. This is further evidence that the gravitational interaction is variable in nature and connected to the energy an object has or is able to generate. The stellar cores in time gain energy which strengthens their ability to interact gravitationally, but this energy comes from their host body. The sun has been severely weakened as a result of the stellar cores interacting with it. The sun not only goes completely dark periodically, it is also getting progressively weaker and less able to emit light as well as produce a solar wind. This can be seen in the fact that the sun's corona is ever growing smaller and darker, and has been doing so for many years now, and also in the fact that the sun's magnetic field associated to sunspots has been progressively decreasing independent of the solar cycle. And for more details, you may look at Article 195 entitled Stellar Cores and the Dying Sun. And here we see a plot from measurements done by Livingston and Penn. And this was actually done during cycle 23. We're now in cycle 24. So between 1995 and 2009, they actually found that the sun's magnetic field associated with sunspots consistently dropped by 50 Gauss per year. And this occurred whether it was close to solar minimum or solar maximum. Consistently, they saw this drop in the magnetic field associated with sunspots. And we can also see that the sun is weakening by simply observing the corona, which is getting smaller all the time. As you can see on the side here, it's continuously getting smaller. This is what it looked like in 2011. 2011 was a year quite close to solar minimum, but yet the corona was larger than it is now. And this was close to a solar maximum, but already the sun was starting to develop huge corona holes. It now has permanent corona holes at the north and south poles, and in fact the whole surface of the sun we can see is so low in particle density that it looks like one big corona hole. And this is apparent from the part of the sun surface that faces the detector, or the STO satellite, and we can see here so many holes opening up because of this low particle density. So the corona is actually disappearing. And we can also see that in how dark the sun has become in the 304 angstrom images detected by the STO satellite. You can see what it looked like in 2011, 2012, 2013, 2014. It was the solar maximum year. As you can see, it was darker than it was in 2013. It consistently became darker and darker in the 304 angstrom wavelength, which shows that it has become drastically weakened. Now, observation of these objects, that is the stellar cores, has led to an understanding of how gravity works, and you may look at the book entitled Planet X Reveal Gravity and Light, or articles 181 and 182, where I detail some of this mechanism which and my understanding of it, which developed from the observation of the interaction between the stellar cores and the sun. But also that the main difference between stars and planets is size. Both stars and planets have solid cores, and both generate energy in their cores from the decay of unstable nuclei or fission. This energy is used to generate an electromagnetic field, and larger objects can generate a larger field, which gives rise to a greater degree of ionization and thus to more emission of radiation than smaller ones. Because this energy is directly related to the gravitational field generated by the objects, I have called it gravitational energy. It is the gravitational interaction resulting from the object's energy status that gives rise to charge separation, so that objects have positively charged cores and negative outer layers, which then results in the generation of the electromagnetic field, which in turn allows light emission. In conclusion, stellar cores are dead stars, or stars that have lost the ability to generate energy in their cores, and that have revealed the true nature of gravity and its relationship to the electromagnetic interaction, as well as the fact that stars and planets are formed and operate through exactly the same mechanism, and that both have solid cores and atmospheres in which light emission processes occur. These objects are destroying the sun's ability to emit light and are also affecting the Earth. And you may see article 201 entitled Africa Breaking Up, a preview of what is to come for more details on that. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.